So welcome everybody to TWIMS. I think many of you have been to the campus before, so I'm not going to do a particularly long, elaborate introduction to the Institute, but I would like to say a few words, and very importantly, I want to position this monthly seminar series in relation to what TWIMS is attempting to achieve in respect of supporting the development of manufacturing in sub-Saharan Africa. In terms of the topic today, I'm giving you the introduction and then I'm also my own guest speaker, which is a bit odd. It won't happen again, as you'll see. But I've been on this journey of trying to understand Industry 4.0 over the course of the last few years. And I really wanted to share some of the challenges that I've experienced in relation to trying to ground and understand what these technology disruptors mean for manufacturing. And what I really want to do is get beyond the hype and the hyperbole and talk about what the potential consequences are for business executives who have to make serious decisions around investing in the future of their business. And that really is going to be the focus of the presentation this morning. So I'm going to be speaking for about 40 minutes on demystifying Industry 4.0. I've got some information I'd like to share with you, and I'd like to provoke some thinking around the strategic space that we need to occupy in relation to engaging with these Industry 4.0 issues. I've left 20 minutes for questions and answers, and I think it's an opportunity for us all to learn from each other in relation to a rapidly evolving space that I don't think anyone can claim high levels of proficiency in. I feel a bit intimidated even talking about Industry 4.0 because half of the things I don't understand myself. And what I have discovered from working in this space now for the last couple of years is that every time I scratch somebody else, I discover they don't know nearly as much as they think they know either. The space is evolving too rapidly. And the consequence of that is a mist, hence the title, Demystifying. How do we try and unpack and understand this emerging space? So I think having some time for questions and answers is absolutely critical because I'm sure there's going to be many of them. Just by way of introduction, the Institute has been structured around 3 levels of activity. So the Toyota Vessels Institute for Manufacturing Studies has a layer of academic activity that is tied directly to the Gordon Institute of Business Science. So GIBS delivers the GIBS PhD, MBA and postgraduate diploma, and we have 2 postgraduate diplomas, one that feeds into the MBA and one that feeds into the PhD program. And we as TWIMS are also GIBS when we deliver our formal academic program. So I actually wear 2 hats. Sometimes I'm TWIMS, sometimes I'm GIBS. And the reason for that is because when we conceptualized the development of the Institute, we realized we needed to have a rock-solid academic partner, and we realized that we couldn't recreate a wide band of knowledge. What we really needed to do was to partner with an institution that was the dominant leading player in the general management space, and that we would rather use our limited resources to develop deep capability over time in manufacturing related focus areas only. And then combine that with the best of GIBS, we have the best of both worlds, manufacturing focus and the general management focus. So that's the partnership that we have in relation to our formal academic program. We call this our sort of core IP block. It's the brain and the spine that holds us together as an institution. And then permeating out of that, we run a range of executive and management short courses. GIBS delivers its suite of management development programs on the campus, and we deliver our manufacturing specialist courses from this particular campus. These called apex focus points are built on what we believe in as the foundation of the Institute, which is creating manufacturing community. So when this campus was conceived, we didn't go out and say, look, what we needed to do is just to build a facility with lots of seminar rooms and lots of technology centers or sort of direct learning infrastructure. We said we needed to create a campus that was going to be inclusive, and it was going to be a place where people would want to spend time. Because a large part of learning is not about the formal engagement. It's about learning from each other, and it's about having those discussions and those engagements around topical issues that are important to the individuals having the discussion. So what we wanted to do was to create a campus that would sit at the heart of manufacturing community. We haven't quite finished the campus. It will all be completed in August. But we have a beautiful swimming pool. We have a lovely gym. We have a running track around the campus. We've invested in a very nice resource center. We have a great computer laboratory. We've invested in a technology sandbox where people can come and play with some of the technologies that we will be bringing into the institute. We've got very, very nice seminar rooms, board rooms. We've tried to create the infrastructure so that it's a place where people can come and think and contemplate all things manufacturing. So even where we are sitting now, this is our temporary teaching area as we complete the build of the auditorium and the classrooms related to the auditorium. And then in August, this becomes a coffee shop and a tea garden extending out into the outside. And the future of TWIMS is really to try and make this a sort of a community hub for all things manufacturing, where industrialists can come and think about how they're going to build the next phase of their businesses in a complex operating environment. So for us, manufacturing community is really important, and that's why we call it the heart, because none of these things matter if you don't have heart. If you're not passionate about manufacturing, if you don't recognize the importance of manufacturing. I believe strongly in the Japanese word, and when Dr. Funzel spoke at the inaugural monthly seminar series, he spoke about monozukuri, which really is about the pride in making things. Because when you make something, you don't just make a product, you make a community through the process of making the product. You make a better society when you make things. And that really is the foundation of the Institute. This is obviously really important for us, is the Manufacturing Focused Mba. It is the pinnacle qualification that we launched with, although I'm very pleased to announce that we will be launching our PhD program from the beginning of next year. I'm hoping we'll have at least 2 PhD students starting with us in February of next year. But the Manufacturing Mba is really important for us because it's the academic vehicle through which we will bring large numbers of people onto the campus. So this year we started with our inaugural MBA class. We only have 18 students. I'm very pleased we only have 18 because there's still quite a bit of changes occurring on the campus, and so therefore it's easier to manage with 18 students. But next year we will grow to our 40 capacity. So we will grow to 40 MBA students, and then from then on we'll be taking 40 students per year. And the Manufacturing Focused MBA once again represents this sort of best of two worlds. We have the core MBA courses, which are effectively focused on in year 1 of the MBA, which is the postgraduate diploma, as well as the start of year 2. And then at the end of the first quarter of year 2, the students never physically leave this campus because, of course, they're here the whole time. But the teaching certainly changes because then it becomes very strongly focused on manufacturing. We've developed 5 manufacturing electives, which on the Manufacturing Focused Mba are not electives, they're compulsory. And they focus on green manufacturing, lean ops management, lean supply chain, future manufacturing, and African trade and industrialization. Those 5 themes are the electives. And then once those electives are done, there's a global manufacturing module where all of our students go off on one of our sort of developed sort of global learning opportunities. Next year it looks like we're going to be going to the United Kingdom. I was at the Institute for Manufacturing at Cambridge University a couple of weeks ago trying to negotiate the use of their facilities and their connections in the UK for our inaugural global manufacturing module for next year. So I'm very excited about that. And we will be expanding that to additional countries and additional options for the future. And then on the Manufacturing Focused Mba, the dissertation has to be manufacturing related, not inside a factory. When we talk about manufacturing, we're talking about the entire ecosystem. So industrial policy, trade policy, all the way down to what happens inside of the four walls of a factory. So this is the focus of the MBA. Next year, when we do have the first set of manufacturing dissertations, we've also got a focus on essentially, once again, to the theme of the best of both worlds, is not only giving the students academic supervision, but also providing a level of guidance from an industry mentor. So we're very keen on building a bridge between the older generation of executives and the new generation. So how do we transfer that knowledge? Academics can't transfer that knowledge. I can talk your ear off for hours as an academic, but when you're engaging on a dissertation, you want to get the best of academic experience and academic knowledge, and you want to grasp those pearls of wisdom that can only come from those individuals who at the coalface have run serious organizations and dealt with the complex issues that you're trying to get your head around in a dissertation in a very practical way when they've run organizations. And we call them the grey berets for obvious reasons. We want to try and bring those people into the institute so that we can impart some of that knowledge and develop manufacturing capabilities as best we can. So that's the Manufacturing Focused MBA. These are our short courses. So in relation to our short courses, this is actually for our 2019-2020 financial year. So in beginning of the year, we ran our Future Manufacturing course, but through until the end of February of next year, we've completed the Green Manufacturing. We'll do Lean Ops in August, Lean Supply Chain in September, African Trade and Industrialization in October, and then the Future Manufacturing course will be run in November. These courses are much more action-oriented. So there's 2 days of theory and lectures and engagement on the Green, Africa and Future courses. Lean slightly different because it's 1 day of theory, 1 day in a factory, 1 day of engagement on learnings, and then another day back in a factory. But these other courses are basically 1 day of exposure to practice and then 3 days of reflection and learning in relation to some of the latest developments taking place. So this is our suite of executive short courses. We ran them last year at the Hilton Hotel while this campus was getting ready. So we're getting nice traction in relation to these executive courses. This is the venue that you're sitting in. About 2 months ago, when we hosted a delegation from Ghana, from Nigeria, and from Kenya. We're working on a project called the Sub-Saharan African Auto Pact. And the beauty of this campus is that it allows one to bring people of a like-minded approach, trying to come up with solutions to challenges and realization of opportunities, to come actually reside on the campus. We've got a very nice hotel on site, 13-bedroomed hotel. And we were able to host the officials. There's our ex-Minister of Trade and Industry, Alec Irwin. And we were able to sort of brainstorm over the course of a few days the opportunities for automotive policy regime within the continental free trade area that is being negotiated. And that's what I mean by manufacturing community. You want to have a space where people can come in a very safe way and engage and think through the potential for the development of manufacturing on the continent. So in terms of manufacturing community, we've invested very heavily in some great facilities. We will be developing company and sector-specific short courses going forward. And of course, we're very keen on doing manufacturing research and strategy development, particularly in terms of long-term duration research projects. So that's the background to the Institute. One of the key anchors of building community is to bring industrialists into the campus space. And we thought the best way to do that is to have a monthly seminar series where we cover a mix of topics, but that would appeal to the sort of broader management and executive leadership within the regional manufacturing space. So we started last month with Dr. van Zyl speaking on manufacturing in a new world. I'm speaking today on demystifying industry. The reason why we've had to move Dr. Hein Muller's additive manufacturing presentation to the 10th, so I know it's only 2 weeks away, is because the campus is having a mini shutdown whilst we prepare the coffee shop. So unfortunately the campus becomes unavailable for a short period when we do the major overhaul of this particular facility that we're in. So we've got Hein speaking on additive manufacturing. Then we've got Rose Atkinson or Heathcote now I should say, of the Lean Institute, who is speaking on lean leadership in Africa. We've got Dr. Jeff Chen in September. He's speaking on artificial intelligence within global supply chains. Jeff has got a PhD in computer science. So he really is the right person to speak to us about the application of AI within global supply chains. We've then got Pat Nodora, who's the CEO of the Busmark Group. And Pat's going to talk to us about manufacturing as an investment opportunity. You may have heard Pat's name mentioned in Parliament. He's one of the sort of key black industrialists who's been investing very heavily in manufacturing. And he's going to be sharing some of his views on the opportunities for manufacturing investment in South Africa. We've then got Michael Grant in November. Michael Grant is the Chief, I think it's Intelligence Officer or Technology Officer of Data Profit. And he's going to be speaking about, what's the big deal about big data. They're doing some really interesting stuff on the machine learning side, and he'll be sharing his expertise with us. And then in December and January, we certainly don't have any guest speakers for obvious reasons. And then we'll start next year with a presentation from my colleague, Dr. Lisa Kenya at TWIMS. She's head of academics here. Lisa will be talking about women as manufacturing leaders, which is her particular focus in terms of trying to understand some of the dynamics of leading complex manufacturing organization as a woman leader. So this is our guest lineup. If anybody's got any wizard ideas, if you're bringing any top international experts over to your organizations for whatever reason, please give us a call or drop us an email. We would love to piggyback off in some way or form. We're trying to bring excellence, trying to bring top-notch people into the KZN manufacturing community. This is our start, but every year we want to have 10 top-notch speakers available so that we can all be stimulated and start asking some serious questions about the future of where we're going. Okay, so that's our guest speaker list. So I'm going to be talking to you about demystifying Industry 4.0. Just by way of background, I'm not a specialist on Industry 4.0. However, I was given the daunting task a few years ago of leading the team that would develop the new South African Automotive Master Plan. And I've done a lot of policy work for government over the last 2 decades, and the way in which policy has always been constructed in South Africa is we have a problem. The policy is not delivering what it's supposed to deliver. Can you please review the status quo and come up with a set of policy recommendations on fixing the problem and taking the industry forward? Difficult enough, but at least you existed in the here and now. You were focusing on the issues that were presently at play, and you weren't asked to do these sort of technology foresight analyses and these long-term sort of prognoses of where the industry was going. In the master plan approach, which I think is really innovative, you start by defining an endpoint in the future and you work backwards from an ideal. So we copied the Asians. A number of Asian economies have these master plans where they say we're not focusing on where we are now because we're not happy with where we are now. We're going to focus on where we want to be. We're going to get consensus on where we want to be. We're going to test the reality of being able to get there. And as long as it's a bit of a stretch, that's fine. If it's implausible, then it's not fine. So you define a future state that is plausible if we got our act together and we operated in concert with one another to achieve it. And we've got the best chance of realizing an appropriate policy set of interventions then on the basis of where we want to be rather than fixing the obvious thing that's wrong now. And so when we took on that challenge, we said, fine, we'll do this master plan and we'll put together the team to do so. Faced an immediate challenge because we were asked, do a master plan out to 2035. And the first question was, well, what do we drive in 2035? Is it going to have an internal combustion engine? Is it going to be battery electric? Is it going to be a fuel cell vehicle? Is it going to be a hybrid? Is there something else happening that we don't know about? Are we going to be driving cars, or is it going to be more technology enabled, or are we going to be completely replaced and we're going to have full vehicle autonomy? And what are vehicles then going to be made of? Are they still going to be made of steel? What are they going to be made of? And if they can't hit each other, then what componentry is going to be in a vehicle? So the real challenge of the master plan then was to say, well, we've got to understand what's happening out there. And we've got to jump forward to 2035. And that started my personal journey of trying to understand these Industry 4.0 issues. Because the last thing you want to do is make big dramatic policy decisions that then take you off in a direction that runs counter to where the technology is likely to drive the evolution of what I call the global value chain, that the big global market system that we operate within. And it's in relation to that I said, okay, I've got to understand these issues. So I selected some conferences and I went overseas. And of course, at these conferences, you ask questions and you listen to much wiser people than yourself. And the thing that confused me the most was you'd go to 10 presentations, all from top-notch people, and they'd all tell you things that were contradictory and often in opposition to what you'd learned from somebody else previously, which doesn't mean that they're wrong. These are not charlatans. These are serious individuals trying to understand the future. What it tells you is that they're not sure. And what I really want to do in my presentation is to start unpacking what this means from a strategy perspective. Because the most important thing in any form of strategy is to start framing and visualizing and making concrete the potential direction of where a market's going to go, where a technology is going to go, and what a value chain is ultimately going to look like. And that really is what I'm going to try and share with you over the course of this morning. So the first thing that struck me when I was trying to understand these Industry 4.0 issues is that it's beguiling. It's very interesting. The nice thing about abstract stuff, of course, is that it's abstract, which means you can talk a whole lot of nonsense about it, and there's no need to ground it. So it's beguiling. It's obviously fascinating. I'm sure you've all had those jaw-dropping moments where somebody demonstrates one of these technologies to you and you go, not possible. How the hell did that happen? I had that at Cambridge University now a couple of times where I just walked away going, I'm perplexed. I have no idea how this thing happens, but they're making it happen and the underlying technology is already there. So it's fascinating. We also know it's evolving very rapidly. So every time we go and engage with this, we see, hold on a second. The thing seems to have moved very rapidly from 12 months before when I previously engaged with the same issue. And it's confusing. So why is it confusing? It's confusing because when we talk about Industry 4.0, we're actually talking about a range of different technologies that are reinforcing one another, but also have their own independent streams. And when those independent streams evolve at different speeds, how they interrelate to one another also the shape changes. So whenever we think we've got a handle on it, we don't, because a new development in some other area changes the convergence, it changes the mix of dynamics that are at play in relation to Industry 4.0. So when we try to understand it, we have to recognize that it comprises all of these elements that are all at interplay with each other. And of course, when we're trying to unpack big data and how big data operates, when you put a sensor on everything, how you then extend big data into the broader marketplace, which means that you then have the horizontal sort of IoT, the creation of these platforms. And then critically, of course, things still get made. There's still a complex global value chain where materials go into components, that go into other components, that go into sub-assemblies, that eventually end up in a final product, that then goes into an IoT world where, well, maybe you're now selling a service as opposed to a product, but there's still a value chain that is created. And of course, industrial IoT is really about those vertical linkages that occur through a value chain. And if there is a steady movement of information in one direction and complete visibility on the various componentry of what is being made moving in the other direction, we have the ability to control, manage value chains in an entirely different way. So the distinction between IoT and industrial IoT, I think, is actually quite an important distinction. The one being more market-led, and the other one really around optimizing the efficiencies and the capabilities within value chains. And of course, these enable this big data in a profound way. And the ability to play with ever larger sets of data, the ability to build in the next bit, which is machine learning, because big data is powerful in its own right. But when you remove the need for humans to engage with that big data, and you build self-learning algorithms that then connect with big data with incredibly powerful computer capabilities, you've now got the emergence of artificial intelligence, which, by the way, is not intelligence. I mean, we call it artificial intelligence. I sometimes for the thing of the dramatic. Whenever I say AI, the first thing that comes through in my mind is Arnold Schwarzenegger. It gives my age away exactly. I always think of the Terminator movie. I can't not. It's a natural reaction because we think of AI in that particular form. AI is not that at all. AI is about algorithms, and it's about self-learning algorithms. And when you start unpacking this world of AI, you realize how profound that is going to be for us and how it's going to change how we optimize and develop commercial outputs, whether they're services or products. Of course, tied to that is the cyborg-type self-adapting robotics, which AI lends itself towards the creation of. So when you have robots, particularly cobots, which is the use of robots in a manner not separated from humans, and they're capable of learning and adapting to their particular environment, you then jump to these sort of very dramatic cyborg outcomes. But the reality is, if a robot is self-learning, it then starts having the flexibility characteristics that differentiate humans from the standard robots that we've had in our factories for generations now. So what are the consequences? What are the consequences of that? Which I'm going to get to. Then, of course, the really exciting space around optimizing factories, optimizing value chains, optimizing products through this digital twinning. This is the stuff that I must say most blows me away when you put those headset things on and suddenly you're inside of a factory or you're inside of a machine. And the ability to see what the physical is going to do before it happens enables one to optimize and change those processes. And you all know from the businesses that you're in, manufacturing is always in a race against commodification, where your margins are always being driven to sort of returns where you can barely beat the risk-free rate of capital in a financial market. And the consequence is these improvements in efficiencies, in building quality into the processes, in genuinely poker-yoking everything in a digital sense before it goes into a physical set of processes, has profound consequences for the levels of performance that need to be achieved in value chains. Throw in virtual reality, throw in augmented reality, and how you structure your production lines. We had a great speech from Yanesh Naidu from Gendermark. Spoke at our Future Manufacturing course earlier this year. And he highlighted how their augmented reality glasses that they now have on their latest production lines allow the reconfiguration of the production line. Because often the production lines required the following of the work instructions, which then forced the physical layout in a particular way. Now that everything is an augmented reality glass, where all of your instructions are coming up on the glasses that you are wearing, you can reconfigure the line and get much better levels of efficiency through the production line. And he gave us examples of how they've reconfigured their production lines as a result of the development of this augmented reality. So we're going to see some major changes. Even in the digital twinning, he showed us how when they do a production line now, they do the digital twin first. The digital twin goes off to their customer, and the customer, while they're building the line, the workers are all being trained in the digital twin on the processes that they're going to be following in the new assembly line. Tied to that, of course, is this issue of visual recognition. It's one of the most powerful manifestations of Industry 4.0, is the ability of AI, the ability of something that inputs into big data to visually collect information, because then it no longer requires the physical inputting of that information by us as humans. So the moment you've got visual recognition, you've got the ability to capture reality, to take that data, input it into a self-learning algorithm, an AI, and start deducing what the underlying issues are. And that's why it's so important to have somebody like Data Profit speak to us, because that's what they did at Atlantis Foundries, where the AI starts learning off the physical analysis of the castings. Sorry. So visual recognition is a very powerful componentry in the development of an IoT-enabled framework and an industrial IoT framework. This is slightly different, but in a way they're linked. When we talk about digital disruption, so when we talk about the digital componentry of Industry 4.0, we're really talking about these elements, because this is all about data, and it's all about the digital connection of things through sensors that allows then this big data to form and for the intelligence to be created through that big data. However, the reason why these two would be connected into them is because when we talk about smart materials, when we talk about composites and we talk about nanotechnology, it's about taking base materials and infusing this intelligence into the functioning of into the base material itself. And when we get to things like nanotechnology, these are incredibly data-intensive development processes. So the reason why we're seeing such advances in materials is because of the application of this digital disruption in the material space, right down to a submolecular level. When we had Theo Look, the CEO of Mete, come speak to us on the green manufacturing course, and of course Mete is one of the world's biggest producers of lead acid batteries. What Theo highlighted is the challenge now as an industrialist is to understand your product down to a submolecular level. And he actually put up the periodic table for our green manufacturing students. And he went through the periodic table and he said, if you don't understand the periodic table that sits under your materials, you're going to be taken out of the market. Because your materials are going to evolve and they're going to be developed because of all of this intelligence here that is going into the evolution of the material space. But of course, there's always a limit to the laws of physics. There's always a limit to the laws of chemistry. Therefore, you've got to understand both the physical and the chemical properties of everything that you do at its most basic level to understand where this could potentially go. And of course, additive manufacturing gets a large amount of focus. And the reason for it is because additive manufacturing, when configured with the transfer of code, with the transfer of data, fundamentally disrupts how manufacturing has evolved over the last 50 years. Because it no longer requires the movement of product, material. It potentially allows all the material to reside in one place and for code to be moved to the material in order for the production to take place. And of course, how has industry developed over the course of the last 50 years? The differential factor cost profile of what things cost. So you chase cheap labor or you chase access to capital at a global level. 3D printing potentially changes that fundamentally. And we're seeing some very interesting developments at the margins that are likely to be moved to the center quite quickly in relation to what this potentially means for global manufacturing organization. So, it's confusing. The other challenge, of course, is that it's both still coming and it's here. So the challenge that I had, and I want to go back to the automotive master plan, because that's the I'm not going to go into the master plan, but it's very clear, it's very specific. We're going to have 1% of global vehicle production by 2035. We're going to drive local content to 60% from the 40% base. That'll double employment. We're going to drive our competitiveness to leading competitor standards. There's going to be industry transformation in the segments of the value chain where national capital can operate. And we're going to see increased value addition within global value chains in specific niches where we've got an advanced materials capability. And then there's all these plans. The challenge is we then go overseas, we go to these conferences, and people tell us, well, the internal combustion engine is dead. And you go, oh, how many battery electric vehicles were sold in South Africa out of the 550,000 that were sold? Oh, 150. Is the internal combustion engine really dead? You know, and so we see this contradiction between it's here, it's highly disruptive, and the whole world's changing. You go and do the market analysis, and you go, where the hell is it? There's no evidence of it yet. So we are the electric vehicles. We are the fuel cell vehicles. Because, of course, they're two big technology, sort of opposing technology trajectories. One is we could go into a hydrogen future. The other one is we go into a battery electric future. Autonomous vehicles. We are the semi-autonomous vehicles. We are the fully autonomous vehicles. Okay, semi-autonomy is here. A lot of our vehicles now have this adaptive cruise control where it brakes for us, and on the freeways, essentially, the cars drive themselves. But why are we still seeing more safety equipment going into vehicles if the ability for them to crash into one another is, as proposed through full autonomy, would change the whole entire economic package of a vehicle? We're not seeing it yet. So yeah, we have a problem. 2035, we're going to have 1% of global production from 0.65% of production to date. We're going to have 60% local content. What does that local content look like? Because if we've got semi-autonomous vehicles, well, if you can still crash into each other, well, then you need to have incredibly advanced safety devices built into a vehicle. If you have fully autonomous vehicles, there's no need for any of that safety because vehicles can't hit each other. It's not possible. If they can't hit each other, then all of the airbags and the side impact bars and the advanced crumple zones and everything else just falls away. Therefore, you don't need to have the structural rigidities and the strengths and the A pillar and the B pillar that you now have in vehicles. Everything changes fundamentally. Evidence? We don't see it. Transport as a service. There's an argument that the future is robo-taxi fleets. And the Boston Consulting Group's done some really interesting modeling of where the automotive industry is going. Are we going to see the death of private vehicle ownership, where we now have transport as a service? Plastic vehicles. Very strong argument that the most important material for the development of the vehicle going forward is going to go steel, aluminium, and then plastic. It's going to be composites. Vehicles will be made out of plastic. We are that. We are the composites. Still very expensive. We haven't seen them yet, except in some real top-end luxury vehicles. Are they going to be 3D printed? There's a company in the United States called Local Motors. Local Motors has got an entirely disruptive business model. It's not very big. Still selling small volumes, but they've got plants around the United States. You go in on a Friday to a Sunday, you go back the following Friday to Sunday, and you drive out with your own personally designed motor car. They've got a bit like a Meccano set. They've got some base underlying sort of drivetrains that you put in, but you can design your own vehicle using CADs. Go online, go to localmotors.com, and you'll be able to design your own motor car. And if you were at one of these micro factories, you can actually go in and 2 long weekends you co-build, co-own, co-create your own bespoke vehicle. When I was in Washington, D.C. a couple of years ago, in National Harbor, Local Motors run something called Ollie. It's a fully autonomous vehicle that they run through National Harbor on a cycle. You can go and see Ollie operating. So you've got these major disruptions where this sort of autonomous vehicle plus your own still personally driven motor car can be 3D printed at their particular sites. It's Mickey Mouse stuff. It's literally a couple of 100 units a year. But it shows you what can be achieved and how potentially disruptive these technologies are. So when we talk about these technologies, they're not in our direct consciousness because they're often at the fringes. The problem is those fringes are moving and we don't determine where those fringes are. So when we hear London stating that they're going to ban the internal combustion engine in London by X, Paris, Norway, a whole bunch of cities in Europe have now followed up, we know that the days of how vehicles are sold is over. Not here necessarily yet, but we also know that if we are only 0.5% of the world's production, hopefully getting to 1% of the world's production, even then, we're never going to direct the momentum. We will have to conform to what the global trajectory is. So what are the consequences of that? And the question that should be asked, I'm giving you the example on autos because these are all the questions we were asking in relation to these future technologies. For every single manufacturing value chain, the same sets of questions need to be asked. What is fringe? What's not? What's core? When is it coming? How rapidly? This is obviously an important one, which is around cobots. It's not about the market. It's not about the digital space. But we talk about the sort of cyber physical world. We don't live in a cyber physical world. We live in a cyber physical social world. People ultimately matter. People ultimately always make decisions. So when we talk about the cyber physical social, how do we deal with the emergence of this AI-enabled robotics? Go and play online once again. Go to, just type in Sawyer or type in Baxter robot, and it'll take you, I can't remember the name of the company now, but you can start building one of these cobots. You can make it look female, you can make it look male, whatever you think is going to be more comfortable for the workers. They cost around $22,000, and these are cobots. The reason why they're called cobots is because they can operate completely safely in an assembly cell with workers. What I find really interesting is I read a case study on these cobots, and I read that the new South Carolina plant of BMW had over 50 of them installed when they did the model change on the X3. So of course, when Pretoria started making the X3, I immediately contacted my contacts at BMW and I said, how many cobots do you have? How many do you think they have? None. They decided that for social reasons and the economics, our labor forces, and there's more variety of models being made. It's only one model, but derivatives of that model, that they were better with a flexible labor force still. So interestingly, no cobots, but their sister plant in the US has over 50 of these cobots. $22,000. Not expensive. I mean, it's basically the cost of a skilled operator over 2 years. Okay, so some changes coming. Then you have those aha moments when you realize actually it's not so far away. So I've presented to you, is it here or is it still out there? Well, we had this experience, and Adrian was with me on that trip. We had the opportunity to take a set of industrialists over to Zara in Spain. Of course, Zara is the leading clothing retailer, and it's over the last decade just been on this relentless march towards sort of global dominance, and it's got this sort of unbeatable fashion model that's built on intelligence back from stores. And this was taken, a photograph that we took on the trip, in October of 2015, almost 4 years ago. That's not NASA. That is Zara's intelligence hub that sits behind every single point of sales terminal in the world. They monitor live all of their stores, all of their point of sales terminals to make sure there's accurate information. When you go and buy a garment from Zara or a shoe, whatever you're buying from Zara, every product has a long list of attributes: color, fabrication, trim detail, pattern, the silhouette, price point, size. And what that intelligence is coming back to them, and they've got this incredibly big data center next to them where they are chewing through this data the whole time to see what color, what pattern, what silhouette, what trim detail, what price point, what size curve should be placed in stores. And then they've got this very advanced logistics process, whereas if something doesn't sell, they have a reverse logistics process. They extract product from stores and they reallocate it to the stores where there's a high clearance, high sell-off rate. Why? Because the biggest problem in fashion is discounting. What us retailers do, and why they're all slowly not doing very well, is because you buy cheap in South Africa, you make a massive gross margin, which often translates into no operating margin as you start discounting the product in your particular stores. Zara's discounting levels are a fraction of the competition because they've been using this for a long period of time. Interestingly, they've always done this, except they've automated it. They've been using big data, they're using the IT framework globally, and they're using machine learning now to augment and do optimal allocation of product through their particular store footprint. So it is already here, and it's operating at scale, and it's not that dramatic, because we like to think of, oh, it's 3D printed, that's dramatic. We're now renting clothes rather than buying them, that's dramatic. Actually, dramatic can be the same old, just done hyper efficiently with a much better connecting point to creating customer value in the case of Zara. So this is 4 years, almost 4 years old. It's already here. So it's both coming and it's here. Question is, can we afford to ignore it? This is often an argument presented in the South African environment. Yeah, that's Europe, that's North America, it's different to us. We've got our own unique problems and challenges. We'll have to cross that bridge in a couple of decades' time, but we have to deal with the basics now. And there's a validity to that argument. Now, we're worried about battery electric vehicles coming into South Africa, when actually a battery electric vehicle would be even worse for the environment than an internal combustion engine because we burn coal. So actually, anybody driving a battery electric vehicle in South Africa is not saving the environment, you're damaging it even more than if you drove a modern, highly efficient internal combustion engine vehicle. On top of that, South Africa's real big problem on the environmental side for vehicles is that our fuel quality is lousy. We are generations now behind the frontier of fuel quality. So the carcinogens in our air could be fixed much more easily by forcing investment in the oil refineries that we have in the country, or actually just closing them down and importing European quality fuel into the country. So the question is, can we afford to ignore it? And there's an argument that one potentially could. I would argue that the reality is we cannot afford it. And we cannot afford it not because of some sort of smart argument around the use of technology or the evolution of the market, but because there's no scope to ignore it. This is a graphic that I came across a couple of years ago, and it changed my thinking completely around the importance of green. And it emphasized to me the fundamental importance of manufacturing technologies being forced to align with the green agenda in the future. The inner circle here is middle class consumer spending in trillions of dollars in 2009. The outer circle is middle class consumer spending in each of those geographical regions in 2030. There's going to be 571% growth in Asia. The world reached the 1.5 point, so we are consuming 50% more resources than the world can handle. That reached that point about 10 years ago, and we're just about to reach the double point. So we are now consuming twice the resources that the world can sustainably provide. The consequences of that are obviously profound. The consequences for us latecomers, so the part of the world that is the next in line to industrialize, Sub-Saharan Africa, is profound. If you think, and you've probably all seen the demographics of it, so of the next sort of growth in the population, over half of the world's population growth is coming out of Africa. If we do create a middle class, which we have to create if the place is not going to have serious social turbulence going forward, we desperately need to create a middle class, which means we need to expand that much more than what is being projected. How do we do that when the planet can no longer absorb the resource utilization that we demand as a middle class in terms of our carbon footprint. It's not feasible. And this was the aha moment I had when you realize Industry 4.0 must not be seen in isolation. When Industry 4.0, when these digital disruptors combine with additive manufacturing, advanced materials, to solve the world's environmental footprint problem and start supporting decarbonization, it will become a fast-track change because legislation is going to drive it. I think what we're going to see between now and 2040 in all of the major markets that we supply is profound jumps in legislation that are going to be highly disruptive. Because legislation is going to drive the market changes, because this is never going to be dealt with by individual firms for obvious reasons, but it is going to be dealt with by governments who are looking forward in relation to the health of their societies. The consequence of that, I think, is very, very clear. Industry 4.0 is going to become a much more substantial sort of influencing point on our manufacturing base, not because of the technology, but because of government legislation that's going to be coming. So, how do we move beyond the technology sci-fi and ground this in business strategy? Fundamentally, how do we shift from it being something happening out there to something we are driving? So, one of the big concerns I have is working on the master plan and then working on subsequent industry development plans for government is you see all this exciting technology taking place, you look at the R&D, you look at the big multinationals and you see what they're spending money on and you can see where the technology is going. And then you're working with the South African operations, and the South African operations are all hold the position, the future's looking bleak, lockdown, guarantee our short-term returns, not focus on these technologies, not focus on these disruptors because we're holding these very defensive strategic positions. The problem then is that technology exists out there. We have to bring it into our space so we can start engaging with it. So how do we shift that? And yeah, I'd argue that there are 3 steps that we need to follow. Otherwise, we're just having lots of general discussions around what this Industry 4.0 means. Because what it means for different companies is going to be different. So we need to make sense of the disruptors. What do each of the disruptors potentially mean? And how do they interface with one another? When we talk about the great convergence, what does this great convergence mean in specific value chains? And I'd argue that we need to be asking these questions. So if I take that overlaying set of digital and other Industry 4.0 disruptors, we have to start asking the question, what happens to global manufacturing? If we have mass customization, what happens to global manufacturing? Will digital platforms drive diseconomies of scale? There's a strong argument manufacturing will displace retail going forward because retail is the connecting point to the marketplace. Well, if manufacturers can directly link to the marketplace, why would you need the retail conduit? And of course, we know how expensive retail is. We know what the square meterage rates are in malls and that type of thing. You eliminate that, you have the ability to create massive more value for the customer through and generate better margin for yourself through the manufacturing portion of the value chain. The growth of additive manufacturing, how will this displace established production frameworks? How rapidly will it change those production frameworks? The use of advanced materials, how will this change what products are made of and how they operate? Big data, AI, robotics, what does this mean for value chain organization? What does it mean for future labor and skills requirements in particular value chains? I'm going to come back to this after I made this point. IoT, how will it change how markets operate? What products are consumed? What products are made? And how value chains are organized? How do these interface with the decarbonization of economic activity? If the green economy is the future, how do these support decarbonization? How do these interface and impact on the fortune at the bottom of the pyramid? By thinking around sub-Saharan Africa, strongly informed by the work of a guy called Prahlad, who wrote a book called The Fortune at the Bottom of the Pyramid. If these digital disruptors can deal with economic issues, and can deal and improve social inclusion and create the opportunity for the provision of market access for the growing, still poor, but the growing income within a rapidly rising set of developing economies, what does that then do for the establishment in terms of production? What products should one be selling? What types of service offering? It's a great discussion for some of you at the Auto Conference a couple of years ago when Thomas Schaffer from VW spoke about the emergence of Uber and Lyft and these transport as a service rather than vehicle ownership as a model for Africa, because you don't have to have enough money then to own a car. You need about $10,000 of income a year to even buy an entry-level motor car. Well, if you've got transport as a service, you could have mass mobility in sub-Saharan Africa, even with very low levels of per capita income. What changes? How do you provide solutions for the growing wealth within still poor markets? And if you can hook into that, how do you create wealth for yourself? So it's some really interesting developments. I'd argue on top of that is this DNA strand. I think if we think about Industry 4.0, we need to think of it as a DNA strand. The one part of the strand is Industry 4.0, the other is green manufacturing. If you can bring these two together, I think that's the sustainable sort of competitiveness edge that firms will secure. This for me is one of my favorite graphs. I'm going to just very briefly touch on it. I just want to make sure I've gone over time. Oof, I have to. I've taken and adjusted it from a book by McAfee and Brynjolfsson called Machine Platform Crowd. And they use this as their as an example. We all understand in our market segment, so whatever value chain you're in, you understand the relationship between the law of supply and demand. There's always a price elasticity. Whether it's a service or a product, there's a price elasticity. And of course, that elasticity leads to your market clearance price, where you can get the most sales at the best possible price. And that, of course, is the crossover point between supply and demand. Okay, Economics 101. The reason why we're all confused by Industry 4.0 is because Industry 4.0, digital, once you've created your master digital file, any replication of it is free. Any replication of it is perfect, and any replication of it is instant. Now you think about building businesses, and I can see a couple of serious industrialists in this room who've built businesses over many years. The biggest challenge is scaling. Scaling in a low margin business. There's inherent risk, and most importantly, there's burn of cash the whole time in that particular growth. It's the reason why people say, well, how can Uber be worth $70 billion that's never made a profit? How can, and they go on and on all the examples. Well, when you start understanding how they change the law of supply and demand, you realize why investors would be taking a position on these investments. Because they have the ability to create immense wealth once they reach scale, like Amazon has done. So, let me give you an example. You buy this phone. Like, I don't know what this is a Samsung S8, whatever it is. So, whatever it costs, 13, 14 grand. Like, how can it cost so much money? Well, the reason why they can sell it for such a high price is because not of the phone, but because of the apps on the phone. So, the value of something that is free, perfect, and instant. So, take the smartphone. Buy the phone, you say, as a phone, it's worth 3 or 4 grand, no more than that. Then, of course, this has got Office Suite, so I can check I can do Word on it, I can send files, I can work on Excel, PowerPoint on it. So, for me, it has value. What happens to the crossover point? It shifts out. Charge a higher price, I'll sell more volume. I've got Netflix on it. Even more valuable to me, I'm prepared to pay a bit more. A bit more volume will now be sold. I use Uber when I'm in Cape Town. So, because I use Uber in Cape Town, it adds more value in my life, the demand goes up. Samsung, all my appliances at home are Samsung. I haven't connected them all except my TV, where I can flick things onto the TV in it, which is great. But in the future, I'll be able to run my fridge and all that off my phone. What happens there? Well, the value goes up. But here's the interesting bit. Because the platform is being created, my kids have the same phone as me. I've got 4 kids. They're all completely different personalities and all very different ages. The value of this phone to each one of them is completely different depending on what they value out of the platform. They're not interested in the Office suite. They're obviously interested in Netflix. My daughter in Stellenbosch absolutely loves Uber because that's how she gets around. But it's the apps that they relate to. And that's the magic of digital disruption. Once you've created a platform, the embedded value in the platform, because it's digitally created, the value changes fundamentally. Whereas we would typically in manufacturing, you've made something, you've made a vehicle, you've made a truck, you've made an item of clothing, it has one value. But what happens when there's a digital layer on top? And that digital layer keeps adding different potential values for customers. It expands the customer base, it expands demand, and it allows you to leverage a whole range of additional revenue streams. And that is why there's so much money going into these digital unicorns, these private companies that have been created in places like Silicon Valley. Because when that happens, the underlying value of what has been created changes fundamentally. And the ability to amplify off it is obviously substantially enhanced. So this is the big disruptor, is understanding that mix. So what happens to the demand versus supply relationship for products? What does this mean in terms of an opportunity and a risk or a threat for all of the established manufacturing activity that we have? Now, to understand this, the disruptors need to be positioned from the short term to the long term because timeframes matter. It's fine as an academic when it comes. Well, as an industrialist, it seriously matters. You invest too early in an emerging technology, you spend a whole lot of money on something that's got no commercial value. You invest too late, you'll never generate the surplus that opportunity presents because somebody else has beaten you to it and has gained the benefit before you can, and you get locked out of, or your market position is damaged. So timing is absolutely everything in terms of strategy. And then, of course, how disruptive are these things? You've got to scale them. Are the disruptions incremental? Are the disruptions going to be major? Are the disruptions going to be existential? They're going to change everything. And we need to start positioning and having that strategic framework in place. So I would argue that this is a great way of understanding those disruptions. This is taken from sort of the innovation literature, but I've adjusted it to tackle disruption. So in any market, if you position your organization, you have a product, it could be a service, but you have a product, a thing that you monetize when you sell it. You have a process, your own internal processes, and the processes of all of your vendors and all of your partners who co-create the product with you. So you have a supply chain and you have your own internal operations on the process side. You have a position. The position is your brand. It's the thing that you add into the value you add into a particular market. And then you have the paradigm. The paradigm is the accepted way of doing things. It's how a market operates, how it transacts, and how money moves through the value chain. It's how value creation is perceived by the users of the product. So these are the 4 P's of disruption. And then we have to make a distinction on the 4 P's is what does a disruption mean in relation to just doing things a bit better at the one extreme to doing things fundamentally differently on the other. And the argument is none of these things are easy to understand, but comparatively, understanding disruption in a product space and understanding disruption in a process space is quite easy to get one's head around. Understanding position, so what does it mean for brand, and the sort of the embedded value of how the market views your product or your position as an organization, a little bit more abstract. And the paradigm is the scary bit. It's the ice industry of Massachusetts being replaced by refrigerators. It's that massive dislocation. Us not buying our vehicles anymore, but rather using a robo-taxi fleet from Uber. That's the existential paradigm change. But we don't want to talk in the dramatic here. We've got to try and locate it within a strategic framework. So what does that mean? I want to use one example, and I'm going to use the fashion industry. So when we talk about product disruption, we're talking potentially quite minor. We know there's an environmental crisis. We know that the use of polyesters and polyamides are going to come under increasing pressure going forward. They could very well be banned in certain markets. When that happens, how do you then, you still sell the same product, but your materials are now biodegradable. But it could be much more dramatic than that. It could be wearable electronics. Because of course, if you combine it with nanotechnology and you can have microfilament in your garments, so go online, you want to mess around, you can see somebody comes out and they've got this beautiful red dress on, and then she very subtly touches something on the outfit, and now it's a blue dress. And you think, how the hell did that happen? Well, the technology exists for it to happen. I'm sure it costs 100 times or 2,000 times more than what a consumer would be prepared to buy, but the point is that technology now exists to enable the wearing of electronics. So that's the major disruption. Because if you could have one item or two items in a wardrobe that have the ability to change silhouette, to change color, put a pattern on it, now what are the consequences for how we buy our clothing? Process. What would the disruption look like for the fashion industry in terms of process? Well, very minor disruption would be things like direct store delivery. If IoT enables sensors and it changes the configuration of the value chain, well then you could potentially not only be doing ratio packing and that for a particular sort of store grid for a retailer, you could be doing individual garment or product direct store deliveries. And then tied to that would be the development of fast fashion as per the Zara example. But the question is, what happens if it's additive? What happens when 3D printing takes hold? So take Adidas, its two biggest recent investments. No longer in Vietnam, no longer in China. They've built their speed factory in Germany and they've built a speed factory in the United States. What do the speed factories do? 500,000 capacity each. They make the top of their range shoes back in the US, back in Germany using 3D printing. Now how did they do it? They made a breakthrough on something called digital light synthesis. They made their 3D printing, they were experimenting with 3D printing to see how far they could take it. And working with their partners, they made the 3D printers 100 times faster through a breakthrough technology. And that then triggered these speed factories. So what happens when they make another breakthrough that makes it even 100 times faster again? What happens to those supply chains that extend into Vietnam and China and the Philippines, etc.? So process disruption. Additive manufacturing is a real potential game changer in terms of processes. Take positions. How are brands defined? Credence values, so recognizing embedded value in a product that not always tied directly to the physical thing of the product, but what the product represents, is going to grow as a market demand. So when we talk about position, it could be just down to own brand. If you can skip the retailer and you can create a social media presence around your own brand, if you can deliver that own brand through an online retailing platform, what does that change in terms of the position of your organization and its brand in the marketplace? Then you start tying it into some of the big disruptors around credence values. There's a wonderful firm, not huge, about R1 billion, I think 60, 70 million euros in Switzerland called Freytag. So in Freytag is great, their products are all biodegradable. So it's great cotton chinos and that, but when you finish wearing them, you chuck them into a compost heap, and 6 months later, everything's been consumed because there's a smart chemical and it reacts to the enzymes in a compost heap. So you can wear it 100 times, 1,000 times. But the moment it goes into a compost heap, the enzymes recognize that they need to start eating away at the garment, and that's the end of the garment eats away. At a price premium, the other interesting bit is they're buttoned. So you don't get zips on their trousers, you get buttons. Why? Because when you buy a new Freytag chino, you take the buttons off. And you clip, and when you buy a new pair, it doesn't come with buttons, you put the buttons back on again. So it's completely recyclable, or it's reused. Go online and you'll see their brand values and how they're positioning themselves. And I think there's some interesting developments in this particular space going forward as to how brands are identified when they use these disruptive technologies. particularly when they're solving this green sort of conundrum that we're facing. And then, of course, and they're tied to that, of course, this is Nike's big drive in relation to using plastic waste to make the soles of their shoes. So they're actually recycling stuff from the oceans, and of course, it's part of their big brand sort of building. On the paradigm change, you think, well, clothing's clothing. We buy clothing. We could buy it online. We could buy it off. Well, actually, there's an interesting development in places like New York. Ladies are not buying clothing. They're renting clothing in monthly wardrobes, which allows them to change their product or their wardrobe, their look and feel when they go into their corporate environment on a month-to-month basis. The big disruptor, though, is this. What happens when the 3D printing is not done by the manufacturer, but the 3D printing can be done by a consumer at home? Go on TED Talk and type this in, and you'll eventually find a lady. The lady comes on, gives a great presentation about the future of 3D printing, and then about halfway through the presentation says a dramatic thing. She says, everything I'm wearing today, I 3D printed at home. Shoes, clothing. She walked around quite gingerly. I don't think it was the most comfortable clothing, but the point is she looked good in the clothing. So aesthetically it looked good, but the key point I'm trying to make here is she was proving that the technology allows her to go out and pass off, I think the handle's probably awful, but you've got this clothes as code. So the minor paradigm change is that when we no longer think of clothing as buying it but renting it, what then happens? Clothing as a service as opposed to clothing as a product. What happens if it's clothes as code? I can tell you from a government perspective, we are petrified in South Africa of this because, of course, we like to tax things. How the hell do you tax this thing? When the code transfers across national borders, how do you put VAT on it? How the hell do you deal with this development? That's the paradigm change. And every value chain has potentially got paradigm changes coming as well. I'm just giving you this as an example. So my final point is around how we factor these disruptors into business strategy. And I would argue that the search step of strategy needs to be amplified. Now, all strategies are complicated, but they're simple at the same time. Because strategy has a search function, it has a select function, and it has a deployment function. You search, the scope is wide. You deploy, you narrow the scope. You select, you narrow the scope. You deploy, you really narrow the scope, and you put all your eggs into the basket that you've now decided on. But I'd argue that there's a real challenge here because I don't see from working with industry a substantial enough focus on the search step of the strategy. So there are many strategy tools to engage with disruption, and there's going to be many more as they evolve over time. In terms of search, there's this four-side analysis, the 4 Ps I've just used, Porter's 5 forces. You can use competitiveness profiling. You can use the Boston box for some of this brainstorming as well. When you're selecting, you've got to put it through a process product matrix. You've got to do risk assessment models. And when you're deploying, you're going to work out how that changes your organogram, how it changes your value to the customer, and how you then organize functionally in order to deliver on value. Here's the big challenge around strategy scope. Search, select, and deploy. So the scope gets narrower as you get to the point of executing the strategy that you've engaged on. The challenge is the resource requirements. Because although we would argue that the search function is onerous and incredibly expensive, actually the search function is the least expensive part of any strategy process. The most expensive part of any strategy is deployment, because that's when you're using the full resources within your organization to make the strategic shifts that you're trying to make. So the simple argument I would make is that one needs to amplify search with one subtle distinction. You need to experiment. So even if the search is saying that the technology is far away, even if the search is indicating that it's not going to have an immediate impact on your business over the next 5 years, I would argue that you need to experiment. And this was validated when I went to the Institute for Manufacturing at Cambridge, where they've got all of these incubating technologies that they are playing with. Because when you look at convergence, We cannot say with conviction what the time frames are for the adoption of these technologies, because the convergence changes that roadmap and it changes the timing sequence. So the fundamental argument is, unless you're experimenting with these technologies, unless you've created the space in your strategic framework to engage with the technologies, you're always going to see the technology as something out there, and you're always going to be focusing on the hyperbole and the big noise. Whereas if you're starting to experiment with it, having 3D printing in a laboratory somewhere, experimenting with it, creating an IoT diorama even of some kind, where you're just trying to see how putting sensors on things could potentially change your product mix. If you haven't started playing with some of the new materials, the new composites coming through, knowing when to move, when to strike, when to move from, I now understand it, I now need to select it as part of my actual strategy, and I better deploy this thing seriously, I think it's going to be compromised. Because the search on a continuum is easy to understand. But a search when there isn't a continuum, when there's the potential for major digital disruption, where there's big jumps or changes in the technology, requires, I believe, some tacit engagement with the technologies. Which is why I think the search function must be complemented with experimentation. The challenge, of course, is, I gave a presentation a while ago and somebody said, well, that was a great presentation, except you left me unfulfilled at the end. And my response was, you think you're unfulfilled? I feel exactly as you do. I always feel unfulfilled in trying to understand these particular issues. We don't know. And the biggest danger is that we get the smart consultants in who hit us with the hyperbole, lots of noise, the dramatic, the excitable, when actually I don't think that that's particularly helpful. I think we need to understand those future technologies, but we've got to bring them close to us. And we've got to start understanding them and engaging with them.